so let me set you up with two examples now, show that. So a little more challenging ones now. E to the x is equal to minus x plus 2 has exactly one root. Okay, one root means only one solution. Okay, then another example. Suppose, so let f be a differentiable function such that f of x is always positive and f prime of x is always negative. Okay, for all x in R. Okay, so for all real numbers, for all x in the real numbers. Show that. So the new function g of x, which is 1 minus f of x over 1 plus f of x, is increasing. Okay. Here are two questions. They're a bit more challenging than what we've been doing so far. Okay, so show that this equation has exactly one root. So I'm going to consider the function. Okay, so let f of x, I'm going to send everything on the left side, equals e to the x plus x minus 2. And I want to see, in other words, I want to show that f of x has exactly 1, 0. Okay, that means that this is equal to 0 only once. Okay, first thing I want to do is I'm going to check f of 0 equals what? If you plug in 0 here, you get 1 plus 0 minus 2, I get negative 1. And f of 1, I'm going to get e to the 1 plus 1 minus 2, so I'm going to get e minus 1. Okay, so f of 0 is negative, f of 1 is positive.
Sorry, sir. How did you choose the number 1? Like, was it just a random number above 0?
Random number, because actually any number above 1 will give you a positive value here. Because obviously e power x increases much faster than x. And they're both positive. So we're going to rapidly exceed minus 2. Okay? Yeah. Okay, so my function is worth minus 1 at 0 and 1 at and e minus 1 at 1. Okay. Next thing I need to do, I need to show, well, actually, I notice that f is a continuous function. F is continuous, of course. There's no restriction on the x here. So therefore, by the which theorem? Intermediate value theorem, right? There is a number, any c in between 0 and 1, such that f of c is 0. Okay, so I just showed that the function has at least one root. And that this root is between 0 and 1 for sure. Any questions until here? But they don't want to show that there's only one, at least one root. They want exactly one root. Okay, so if I'm to show what's going on here, at 0, it's worth -1. And at 1, it's worth e minus 1. I don't know, 1 point something. Okay. And so definitely, since the function is continuous, we know that it will cross the x-axis at one point by the intermediate value theorem, which we explained already, and we did a few exercises on this. Now, how will we show that it has exactly one root? Well, it's just enough to show that either the function is always decreasing or the function is always decreasing. Because if it has two roots, well, it needs to come back down. Okay, and so it needs to be negative, increasing and decreasing, or decreasing and increasing. If it's always increasing or always decreasing, for sure there's only one root. Is that okay? Okay. So let's find f prime of x. Okay, so f prime of x is, so the derivative of f is just e to the x plus 1, which is definitely positive. Okay, e power anything is always a positive number, plus 1, well, that remains positive. So f is always increasing, and so f has exactly one root. Okay, or 1, 0. That's it, we showed it. Okay, the second one here. So let f be a differentiable function such that, okay, f is bigger than 0. So there is no problem on the bottom here. There's no risk that this bottom denominator could be 0. No problem there, it's positive. And f prime is negative. Show that g of x is always increasing. So basically, I just want to show that the derivative of g is positive. So we want to show that g prime of x is bigger than 0. That's what I want to show. Okay, so let's find g prime. So there's a quotient rule here. So 1 minus f of x. I'm going to do all the steps because it's been a while. Derivative of top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. Okay, equals, so the derivative of 1 minus f is just f prime. So f prime of x times 1 plus f of x minus 1 minus f of x times, and this is f prime of x, over 1 plus f of x squared. Okay, and on top, well, things will cancel nicely. You see that you will have oh, I forgot there's a minus here. Right, the derivative of negative fx is negative f prime. So you will have negative f prime minus f prime f minus f prime x plus f prime f. Okay, so the top, if you simplify this, you will just get negative 2 f prime of x. That's what's going to be left on top if you open up everything, over 1 plus f of x squared. Okay? But they told me that f prime of x is a negative number. So this is negative. So -2 times negative, the top is positive and the bottom is squared is positive. So since f prime of x is negative, then obviously this whole thing, g prime of x, is positive. And that's it. It's done. All right, let's do another few more. Okay, so these are a bit more challenging because they require the theorems and it's a bit of proofs. Okay, let's try one here. Find the absolute maximum and minimum of f of x is equal to 2x over e to the x on interval 0, 10. Okay. Maybe one more here. How many tangent lines to the curve f of x equals x over 2x minus 1 pass through the point -7 and 1. Okay. And at which points do these tangents touch the curve? There you go. Two little questions. Okay, try it out. So as usual, we do the derivative, find the critical numbers. F prime of x, so derivative of top times bottom minus top times derivative of bottom over bottom squared. And this has to be 0. So I could factor out in 2e to the x times 1 minus x, and on the bottom I have e to the 2x is 0, and I could cross out one of the e to the x, so it's 2 times 1 minus x over e to the x equals 0. The only possibility is, of course, if x is 1. So that's my only critical numbers, x is 1, and I replace x is 1 in my function 0 and 10, and that's it. So f of 0, f of 1, f of 10. So f of 0 is 0, f of 1 is 2 over e, and f of 10 is 20 over e to the 10. Okay, so definitely this is the minimum. And I'm guessing that this is the maximum.
How is 0 the minimum?
Sorry?
How is 0 the minimum?
It's the lowest value.
20 divided by e to the 10 is 0, 0, 0, 0, 0, 0. It's really small.
But still bigger than 0.
Oh, all right, right.
Right. Okay, questions?
Yeah, I have a question. Like when I simplified it, I multiplied the 2 times e to the x to the minus 2x ex. And then like I had 4x e to the power of 2x, so I just crossed those off. Like, what's wrong with?
I don't understand where'd you get the 4 from?
By multiplying the 2.
Did you get the same
yeah.
derivative here? Did you get the same as me?
Yeah.
Okay, so
Yeah.
what did you do after that?
I multiplied like 2ex to 2x e to the power of x. Yeah.
Multiply this and this?
Yeah.
Why would you multiply them? It's minus.
Oh, okay, yeah.
Okay.
Oops.
No problem. Okay. Any other questions on this one? That was an easy one. Okay, so these are they're all exam questions, by the way. Okay. This one here, I guess you had time to do it, so I'm going to do it. How many tangent lines? Okay, so let's find the derivative, okay, because we're going to need the slope. So f prime of x, the derivative is 1 times 2x minus 1 minus x times 2 over the bottom squared 2x minus 1 squared. And that is 2x minus 2x disappear, so I have just negative 1. So negative 1 over 2x minus 1 squared. This is the derivative. And so I have my, what's the situation? The curve. I have a point here, x, y. I have the point somewhere, -7 and 1. And we want to know what is that point here. Okay, so basically I want the slope between this and this xy and -7, 1 to be equal to this. That's what I want. Okay, and of course y, don't forget, y is x over 2x minus 1. Is that okay? Good, you with me? Okay, so the slope between this point and this point has to be equal to the derivative. That's going to be my equation that will allow me to find what x is. Questions on the logic? Okay, so let's do. We must have, so y2 minus y1. So x over 2x minus 1 minus y1, which is 1, over x2 minus x1, which is plus 7, has to equal to the slope, the derivative, -1 over 2x minus 1 squared. This is the equation that I need to solve in order to find all the values of x. Okay, so I'm going to skip a few steps because this is just basic algebra. So here we'll have x minus, and I'm going to find the common denominator here. So 2x minus 1 over, and this 2x minus 1 goes on the bottom, 2x minus 1, x plus 7 equals -1 over 2x minus 1 squared. Okay, so obviously don't forget that my function is not defined at 1/2. Okay, so from here, x is not equal to 1/2 for sure. Okay. So on top here, I have 1 minus 2x. No, sorry, I have 1 minus x on top. Well, since x is not equal to 1/2, I could definitely cross a 2x minus 1 from each side. Okay, so on top here I have 1 minus x. On the bottom I will have x plus 7, and here we'll have -1 over 2x minus 1, since x is not equal to 1/2. I could get rid of them, one of them. And that's what I need to solve. So I will multiply this by this and this by that. So I will get, I'll do it in one shot. So 2x minus 2x squared minus 1 plus x equals to -x minus 7, which means that I have 2x squared. So I'm running out of space here. 2x squared minus 2 minus 4x and minus 6 is equal to 0. If you solve this, I get x equals, on a separate paper, so I get x equals -1, or x is equal to 3. So there are two values. Okay, so how many tangent lines? Two of them, at x equals -1 and x equals 3. And what are the points? Okay, so when x equals -1, plug it -1 in here, I get -1 over -3, so it's 1/3. So -1, 1/3, and the other one is 3, and 3 over 5. And this is what I get for my 2 points where the tangent passes through -1, -7 and 1.